So in this video, we're going to do an extra example of approximating a definite integral, so in particular the definite integral from 0 to 4 of 2x dx using area. Okay, so we're going to use 4 rectangles. They all have equal width and the midpoint approximation, okay, for just to be different in this one. So this function is sort of easy enough that you could graph it. Okay, so this is what we're going to call little f of x. Okay, it's 2x. So that's the function we're sort of interested in graphing or in approximating the integral of. So it's going to be a line with slope of 2. Okay, so it looks something like this. Okay, so that's sort of our function. Now you don't really need the function in order to do this. So if we're going to use 4 rectangles and we're going from 0 to 4, that means that delta x is 4 minus 0 over 4. So b minus a divided by the number of rectangles. So that's just 1. Okay, so they each have width 1. So you could just break up your interval. Okay, so you're going from 0, 1, 2, 3, and 4. Okay, so that's actually going to be where the rectangles, the sort of endpoints for the rectangles. Okay, so we get 4 rectangles there. So we want to use the midpoint. So in each one, we're going to take the middle point. Okay, so the midpoint, maybe I should write this. So to find the midpoint, it's the average of the endpoints. Okay, so maybe I'll write midpoint on the interval from x1 to x2 is going to be the average of these two values. So you add them and divide by 2. Okay, these ones are actually easy enough that we just know them. Okay, so halfway between 0 and 1, that's going to be 0.5. Halfway between 1 and 2, 1.5. Okay, so all the 0.5. So 2.5 and 3.5. Now we're going to use those heights, so those y values, to find the height of our rectangle. Okay, so that's going to be the height of each of our rectangles. Okay, so our rectangles are going to look something like this. Okay, now here, because we have some over parts and some under parts, it's actually hard to say whether or not this is a over approximation or under approximation. I'm just filling in my rectangles here. But it turns out actually that we're going to get the exact answer here, which we can find out. But that's how you would find the midpoint if you had to. Here we just know what they are. So when we're approximating, I think I can go, maybe I'll go up here. So the integral from 0 to 4 of 2x dx is going to be, so with our 4 approximation, we're going to have to add up 4 things. So it's the area of a rectangle 1 plus the area of rectangle 2 plus the area rectangle 3 plus the area of rectangle 4. Okay, now to find these things, it's the width times the height. So each one has a width of 1, so that's delta x. Okay, but the height varies. So the height of, say, the first rectangle, this is the f value evaluated at 0.5, using the x value of 0.5. Okay, so we're going to do the width times the height, which for the first one is f of 0.5. Okay, and then we have the width times the height, and for the second one we're using 1.5 as our midpoint. So then we're going to have 1 times f of 2.5 plus 1 times f of 3.5. Okay, so this one, you don't have to multiply. Okay, so to find f of 0.5, you can use the equation. Okay, so it's 2 times x, so this is going to be 2 times 0.5 plus 2 times 1.5 plus 2 times 2.5 plus 2 times 3.5. Okay, so that's 1 plus 3 plus 5 plus 7. So we get 16 is our approximation. Okay, now this one was all positive, so the function was always positive. If you had a function that was below the x-axis ever, you don't care, okay? Because we're talking about the definite integral, we don't care where the areas are negative, we just count them as negative. Okay, so we would approximate our definite integral as 16. Okay, now this turns out to equal the definite integral. Okay, so it's dead on, since the area under f of x is equal to 2x is a triangle, right? So you can see, maybe I'll use a different color. So it's this area here. Okay, so it's a triangle, and it has a bottom of 4 and the height of f of 4. Okay, so we can actually compute the area of that exactly. Okay, so the area of the triangle is 1/2 the base times the height, and the height is 2 times 4, which is 8. So it's going to be 16. Okay, so it's the same. So that, since it's always above the x-axis, that's actually equal to the area, to the definite integral 2x dx from 0 to 4. Okay, so here we actually got the exact approximation using the midpoint, but that doesn't always happen. That was just lucky. And we can only check it really because we have the triangle. Or you could use, now that we know the fundamental theorem of calculus, you could use that as well. So if maybe let's just do that for practice. Using the fundamental theorem of calculus, from 0 to 4, 2x dx. This is x squared evaluated from 0 to 4, which is 4 squared minus 0 squared, which is again 16. So you get the same answer.